Okay, let's talk about unit testing. So on Friday we introduced unit testing, talked about what it is and how to use it a bit. Today we want to go a little bit more in depth and mostly do examples today. So today we're going to spend quite a bit of time in IntelliJ finally, get some live coding, get some examples out there. So let's do that. So a reminder from last time testing doubles. This is how we're going to test a double. We never test doubles using equal. We're always going to test doubles with some allowed tolerance. It's up to each application. It's up to you to decide what an appropriate tolerance is, but choose some appropriate tolerance that's going to ignore truncation errors but not interfere with the logic of your program. So if you have too large of a tolerance, it might just be too loose and accept too many solutions. If you have too tight of a tolerance, it might not get rid of truncation errors. You have to decide what's appropriate for each question. So testing doubles is what we need to do for task 2. And don't forget the expected deadline for task 2 is going to be Wednesday morning, so that's coming up pretty quick. So task 2, you have everything you've had since Friday, everything you need to do to solve that, and get that expected deadline. Moving on to task 3, you're going to get everything you need for task 3 today as well, actually. And then Wednesday and Friday, we'll talk about memory diagrams. For task 3, we have 2 different methods, one that returns a map and one that returns a list. So let's talk about how to test these. Like, we know how to test doubles, and I didn't really talk about it, but we know how to test ints and strings. You just use equal. So if 2 ints are equal to each other, we're good. If they're not equal to each other, they're at least off by a whole value, and we're going to call those not the same if you're off by an entire integer. Strings, you just use equal. It'll test if they have the same value. If you're coming from Java, your instructor should have told you never use equal to compare strings. Always use dot equals. That's not the case in Scala. In Scala, you just use equal. Equal in Scala actually calls the dot equals method. So we don't have to worry about it. There's no actual equal in Scala. It always calls the equals method for that particular type. So if you're wondering why I'm not talking about that, if you have a Java background, that's why. If I was teaching this in Java, I would say don't use equal for strings, always use dot equals. It's just a difference between the 2 languages. So let's talk about maps and lists. How do we test a map? The nice thing about maps in Scala is we don't really have to overthink it. We just are going to use equal. When we use equal to compare 2 maps, the comparison is going to do 2 different things. One, it's going to check if the 2 maps contain all of the same keys. And then it's going to see if each of those keys map to the same value. And all the comparisons are going to be using equal. So we have to check if we're saying equal, do these 2 maps equal each other? These 2 maps are defined out of order in different orders. But remember, in key value stores, the order doesn't matter. It's a key value store. These keys map to these values. It doesn't matter which order we add things to these maps. So even though these are different orders, Scala is going to say, do these 2 maps contain the same keys? Well, yeah, they both contain the keys 1, 2, 3, just in different orders. And do these keys map to the same value? Okay, this map 1 maps to 15. This map 1 maps to 15. Does 15 equal 15? Yes. We can go through each key value pair, and these 2 maps have all the same key value pairs. So these will be equal according to the equal method. So this is going to pass. This test passes. Keep in mind that it does call equal. So if you have something like a map of strings to doubles, we can't use this nice clean syntax. We would have to actually go through our maps and manually do comparisons so we can get our tolerances in there. But I'm generally avoid those in 116 because it's just tedious. It doesn't really test your knowledge or understanding of the concepts. It's just tedious to go through, iterate through your maps and manually check them. So I usually give you strings and ints, things that you can use equal on. That's how we compare 2 maps. Don't overthink your maps. Just straight up equal. Are these 2 maps equal? And Scala does a lot of work for us. All right. Any questions on comparing maps? Okay, and then list. So the second method in task 3 is going to return a list. And things get a little bit trickier, but really it's just one thing we have to remember when we're comparing lists, is that the order does matter when comparing lists. We still get to use equal equal, but Scala will check the order. And the order is very important. The order is sacred to Scala when using equal equal here. So if we have these two lists, Scala is going to make two checks, but two different checks than when comparing maps. The first check, are these lists the same length? If they're not the same length, we're done already. Those aren't the same list because they don't have the same number of elements, and you just return false right away. These two lists do have the same length. So what Scala is going to do is go through these lists index by index and call equal equal on each pair of values at each index. So Scala is going to look at index 0 and say, does 1 equal 2? Well, that's already false, so these are not the same lists. These lists are not equal. And it's going to return false right away. If these were the same, it would advance, does 2 equal 3, does 3 equal 1? And it's going to check each element, each pair of elements as it navigates through both of these lists simultaneously. If any pair of elements aren't the same, according to the equal equal method for that type, we're going to return false. Those aren't the same lists. So what happens when we care about the values of a list, but not their order, which is the case in a lot of the tasks for the homework. For task 3, it's the above average cities, which returns a list of all the cities in a country that have above average population. Nowhere in that method does it say anything about the order of the output in the method description on the homework. It doesn't say return the cities in this order or whatever. It doesn't say anything about it. So when it doesn't mention the order, any order that's returned is correct, as long as it contains the above average cities. So when you're writing your test, you have to ignore the order and accept any list that contains the correct output in any order. So the quickest way to do this, you can see it on the screen, just sort both lists. This is my favorite quick and dirty way. There are, of course, many, many different ways you could solve this. My favorite, sort the list. So sorted in Scala is going to return a new list containing all the same values of the original list, but in sorted order. So if we take list 1, sort it, list 2, sort it, when we want to compare two lists, if these two lists contain all the same values, then we sort both of them, then they're going to contain the same values in the same order and be identical according to the equal equal method. These are going to be the same list if they contain the same values. So in your task 3, when you get that list of your above average cities, sort it. Now it doesn't matter what order they were returned in. You sort it, you know that they're in sorted order. If you sort the list that you're expecting, the list of cities you're expecting, and the list that you got from the method call, and then compare them with equal equal, now you're going to get the comparison that you want. Does this list contain the right cities? Very important. And make sure that you're sorting both your expected output and what's actually returned from the method. So when you call the method that you're testing, you don't know what's going to be returned. Specifically, you don't know what's going to be returned from the correct solution in AutoLab. So you could always have the right order in your code. Maybe you're sorting at the end of your method before you return the values, but my correct solution in AutoLab isn't. So we have to make sure we sort. Whatever we get, sort it. Now I don't care what order it was in. It's sorted. It's in sorted order now. I don't care what it used to be. So in comparing two lists, when you don't care about the order, you just care about the values, sort those lists. How does .sorted actually sort the list? Oh, good question. I believe it's a modified merge sort. In a lot of languages it is. I think it is in Scala as well. I forget what exact sorting algorithm it uses. But it uses a sorting algorithm, sorts the values efficiently in n log n time, and then returns a new list with those values in sorted order. with that, let's jump to IntelliJ and see some examples. So for the first example, I want to test a method that takes a string and returns a list containing all the anagrams of that string, where an anagram is any way that you can rearrange the characters. So given a particular input string, return all of the strings that can be constructed by rearranging the letters of the input string. So that's the method that we want to write. Sorry, that's I can't get that one right apparently. That's the method that we want to test. So I'm going to show you code for this. For anagrams, I got this method here, and it should just look like a mess of code right now. I do not have the expectation that you could follow this code and read it and figure out what it's doing. This is beyond what I would expect from you at this point. Feel free, if you want a challenge, you can go into the examples repo, take a look at this code, and try to follow it, see exactly what it's doing. You'll do pretty good probably until this point where you have a method that calls itself, which is called a recursive method. At that point, you'll probably get pretty tripped up. But you might be able to slog your way through this and understand it, but I would not expect you to be able to at this point in your coding careers. So how are we going to know if this code does what it's supposed to do? How are we going to have confidence that a piece of code is implemented correctly without just slogging through the code and reading it and verifying ourselves? And of course the answer is unit testing, because of course this is what we're talking about these past 2 days. So we're going to write unit tests to test that method instead of just taking on blind faith. Well, my professor said his code's right. Let's just say it's right then. We want to write test cases to gain confidence that that code is actually correct without knowing particularly how that code works, like specifically how it works. So let's write some test cases for that code. And our goal here is to write enough test cases that you're confident that method is correct without even knowing how that method works. That's what we want to do with our test cases. Any code that passes our test cases, we should be reasonably assured, reasonably confident that any code that passes our test cases is correct. And if we're not that confident, we should write more test cases. Write more test cases until you're confident. All right, so let's write this thing. You'll notice when I do live code, a lot of times I'll code out of order. This is just the way I code. I'll code in the order in which I think of things, not necessarily the order of the method top to bottom. So you'll notice that as I code. I just want to give a quick mention of that. But when I'm coding, I want to delete this actually. That'll be the first thing I type. But so when I'm testing a method, the first thing I know I'm going to need is to call that method. And please call the methods when you're testing them. It's not too common of a mistake, but I do see it each semester, 1 or 2 students, where you write test cases and you never call the method that you're testing. Maybe that's not an issue now that I give you a sample test suite for task 1, but I've seen it quite a bit. Bless you. So I'm going to call the method that I'm testing on some string and grab its output. So I'm going to have the actual output. This is what the method returned. There's going to be a list of strings. This is going to be the actual output of the method. I called the method. This is what that method gave me. Now this method exists in a different package than where I'm coding, and this is true with pale blue dot as well. The method exists in a different package than where my tests live, so I have to import that method. So I'm going to write my import statement and give it the path from source of where to find that code. So import, I'm in the live coding directory. .lo1, because we're in learning objective 1. .anagrams is where that code lives. So I'm going to import that and then call my method not just with the method name, but with the object name, anagrams object dot call the anagrams method. I have an anagrams object and then a method named anagrams inside that object. This is the same thing with pale blue dot, and you can see this in the task 1 sample testing. You're importing pbd.palebluedot, And then when you want to call your methods, pale blue dot, dot, whatever method you want to call. Same thing that we're doing here as you'll do on the project. So now I'm calling the method that I want to test, and I'm going to assert that the actual output equals whatever I expect from that method call. So I'm going to assert something. I don't know what that's going to be yet. So at this point, now that I have that structure set up, I want to start thinking of my test cases. And don't worry, we'll come back to that and fix the error, of course. But now I want to write my test cases. I like to organize my test cases in a map. You've seen this in the code very briefly in Friday's lecture. I flashed it up, and it's the task 1 testing. You can see maps there as well. But I like to create a map of test cases that's going to map the inputs, a variety of inputs, to their expected outputs. So in this case, I have a string as the input and a list of strings as the output. And that's going to equal some map of test cases, and I usually call this test cases. You can see how I code things out of order. I'm thinking of the type, and then I'll name it later sometimes. You'll see that a bit. It's just, I don't know, the way my brain works, I guess. And in Scala, we can use multiple lines for our initializations here. So when I'm creating this map, I'm actually going to create multiple lines. I'm going to use one line for each test case instead of having everything like we could put everything here and just have a really long line with all kinds of stuff in this map. Instead of doing that, I'm going to take advantage of this ability that we have in Scala to have multi-line initialization, and I'm going to create my test cases here. Now it's time we want to think of some test cases to write. And I'm going to start with common test cases. What are just the standard input-output behavior of this method? And I always blank on thinking. I need like a three-letter word because I don't feel like typing all kinds of anagrams. I need a three-letter word where none of the anagrams are going to be something inappropriate. So I never think of it on the spot. But let's say if tie is the input, one of the anagrams is always the input itself. And then the rest of our anagrams are any way that we can rearrange these letters to create a new string. E-I-T, E-T-I. I said it right and typed it wrong. I-T-E, I-E-T. So those are all the anagrams of the input tie. Let's get sure, it's fine. And let's get one more in here. Let's get a two-letter one. There are only two anagrams of a two-letter word, just the input and then the input reversed. And with that, we'll come up with more test cases. We're not done with test cases yet. But I want to finish up my syntax that I'm using down here. So I'm going to have a map of test cases. And I want to iterate over those to check each test case, to run each test case. In Scala, iterating over a map, we can iterate over keys and values simultaneously. We can name them whatever we want. I'm going to give them meaningful names here. Input and expected output in test cases. I'm going to call my method on each input to get the actual output that was computed by that method. And I'm going to make sure that actual output is equal to my expected output. If it is, then I'm happy. If it's not, then I'm not happy. There's one problem with this that we just talked about. What's my issue here? Bless you. So we can run this. I like to right-click and go to run. I'm claiming that my code's correct. I'm pretty confident my anagrams method is correct. Crap, I'm failing my test cases, though. Height, tie, eddy, blah, blah, did not equal tie, te. Yes. Got to sort them. One of the key takeaways from this lecture. I got to sort these things. So if we look at the output from the test case, the library's given me quite a bit of information here. It's saying what the expected and actual were. And they're all the same values. Like my method returned a correct answer, but it's not identical to the list that I'm comparing. So we slap a couple dot sorteds on here. Make sure you sort both make sure you sort the actual output for sure, 100%. Make sure you're sorting that. You can just be very careful and type these in sorted order. I don't like doing that. I don't like thinking harder than I have to. So I'm always going to sort my expected output as well. I don't want to take a chance of having one typo where I had one value out of order and all of a sudden I have an hour debug cycle on my hands where I'm pulling my hair out trying to figure out what's going on. I'm just going to slap a dot sorted on that too. It's not going to cost me that much to sort 6 values that sorts in milliseconds. I don't have to worry about that. So I'm going to sort both of them and then compare. Now I rerun this. And we can gain a little bit of confidence that my method is doing what it's supposed to do, assuming that it does pass. Hey, there we go. So we're gaining a little bit of confidence, but not a lot yet. Yeah. I can try. Yes. Yeah, so the tests, when I'm testing your functionality, yes, it's going to sort. Yeah, the tests in Autolab are going to do what they're supposed to do to make sure that any correct output is going to be marked as correct. And then your tests also have to do this. So the issue, one of the common things, I kind of mentioned it earlier, but now that we have some code to look at, is if you're not sorting here, and what I see some students do, this is a decently common office hour question, is in their method, they're going to sort. And they're going to say, I don't have to sort in my test case because I sorted in my method before I returned. I don't know why I always see this one. It's a misunderstanding of how Autolab works, I think. So they're saying, I don't have to sort here because I already sorted there. The problem is, this method that's being called when you submit to Autolab on a correct solution, it's being called on code that you've never seen before. It's my correct solution code that's sitting on Autolab. You've never seen that code before. You don't know anything about the order in which it's going to return. It's just going to return the correct values. So you have to absolutely 100% sort this actual output. So I'm probably not going to return the values in sorted order in my solution, and of course, spoilers, I'm not, because I want to make sure you remember this. I'm not returning things in sorted order. Your test cases have to accept every possible correct solution, not just a correct solution. You have to accept every possible solution that is correct. So sort and then compare. Okay, so we got 2 test cases. Who's confident that my code has to be correct if it's passing these 2 test cases? Yeah. You are confident? Yes. Oh, man. You got a low bar for me. I guess we're good. No, we want more testing here. So there's a lot of mistakes that my code could make and still get these 2 test cases. So this is pretty good for the common test cases. These are pretty standard input-output. If we get these, we at least have the standard behavior of our method going well. But what if we have something like double letters? This is where we want to start thinking of the uncommon test cases. What are the test cases that can start, what are the inputs that can start tripping up a method that a developer might not have thought of when they implemented the method? So let's try some double letters. And here we want to list the anagrams. Like we're going to have 6 anagrams. We have 3 letters. There's 6 combinations. But 3 of them are identical to the other 3. We just want the anagrams. We don't want duplicates in our output. So we want to make sure that our code is going to handle that. We want ill, lil, and, oh man, my brain, li, whatever that is. And let's go a little bit crazy with the double letters. What if we have a whole bunch of the same letter? We want to make sure our code's going to handle that. And I'd want to do a longer word too, maybe do a 6-character word with 2 sets of doubles. I would want a test case like that, but I'm not going to make you watch me sit and type up every anagram of that. 6 anagrams is as far as I want to go. And then we always have, so we got the common cases, uncommon cases, and I want the edge cases too. How's this method going to do on the empty string? So the empty string, we're going to say, just by the problem definition, I don't think I specified this on the slide, but for the empty string, we want to return an empty list. We don't want to return a list containing the empty string. We're just going to return an empty list and say there are no anagrams of the empty string. Would be the what I would define the expected behavior of this method. So with that, we're getting a little better. This is, given more time, if I'm sitting down and doing a homework assignment, I'm going to write up more test cases than this. But for a lecture, limited time, I would be happy with these test cases. We have the common cases, just standard input, output, some stranger cases that I'm thinking up, the edge case. Importantly, what I have is a good variety of test cases. When you're coming up with test cases, variety is much better than just a large quantity of test cases. If I had 10 test cases that all have 3-letter words with 3 different letters with no duplicates, I'm really just testing the same thing 10 times. It's very, very unlikely that any code could get 9 of those test cases but fail on the 10th one, unless the code says, like, if you see the letter E, ignore it, or some silly thing like that somebody might code up. But you're really testing the same thing 10 times. If you have a nice variety of test cases, I got a 3-letter word, a 3-letter input, a 2-letter input, a duplicate letter, a lot of duplicate letters, and an empty string. All of these are testing something different. Each test case is looking for a different specific bug or bugs that might be present in the code. So I want to test for a lot of different things. I've seen students with huge test suites that are really just hammering the same functionality over and over and over again, and then not getting credit in Autolab. And I always say, get more variety, different test cases, testing different things. Was there a question up there? Yeah, what's up? So you wouldn't, for the application objective, you wouldn't sort that because the order is specific. It has to be that city in a specific order. Let's run this, see if my code's passing on this test suite. And now we can build a little bit more confidence of if that method is doing what it's supposed to be doing. It's getting a good variety of test cases. It's passing all of them. We're building confidence. We could go on forever writing more and more test cases, of course. For a lecture, I'm going to cut it off here. But the big question that we all have to ask ourselves as developers is this enough testing? In this class, you have to at least hit the Autolab bar. Autolab has to be happy with it. Autolab would probably be happy with this test suite. But when you get out there in the real world, how much testing is enough? How much testing do you need to be sure that that code, when you release it, isn't going to have bugs? When you release to millions of customers, how do you know it's not going to have a bug in it? How much testing would you need to write to satisfy yourself that, yeah, I'm passing these tests, there's no way there's bugs in there? Of course, there's always the off chance that there's something in there, but getting a reasonable confidence that your code is correct. This is a good start. I would want more test cases if I was releasing this to production, but that's a good start, a good variety. So we can use equal for lists, but if the order doesn't matter, sort those things before you're comparing, before using equal. If the order does matter, don't sort. If the order doesn't matter, like in test 3, sort those things. Easiest way to make the order not matter, just sort them. And then how much testing, I already mentioned this earlier, but how do you ensure code is correct, especially if you don't know what the code is doing? That anagrams method, maybe you can read it, but it would at least take you quite a while sitting down and tracing through line by line and convincing yourself that it's correct. But if you just look at that test suite we wrote, I bet you can read that in an instant. You can just look at the inputs and outputs, say, yeah, the inputs and outputs look good. And then, oh, it's passing that test suite? Yeah, I'm pretty good with that code. Must be doing the right thing. A lot simpler to see in a lot of cases if the code is correct. And when you're generating your test cases, don't use your code to generate test cases. This is a common mistake that I see a lot of time, which shows, I don't know, just a misunderstanding of what's happening, or I think in most cases just laziness or trying to be efficient. What some students will do is write their code first and then call their code on a bunch of inputs to get the outputs and then use those as their test cases. If you do that, what did you test? Nothing. You didn't test anything. If you're using the code that you're testing to generate your test cases to test that code, you just use the code in every step of that process. You're not actually testing anything. When coming up with test cases, it's important to verify them manually. Actually sit down and come up with those test cases. I'm not using any code to come up with them anagrams. I'm looking at the input string, using my brain to figure out all the anagrams, and then using that as my test case. For the project, this means a lot of looking through the cities.csv file and manually picking out countries and regions and making your test cases off of the raw data in that file. Don't call your code to generate the test cases. That's how you get fail the correct solution in Autolab, because your tests are broken, because that'll work. Now, mind you, it'll work if your code's right and you one-shot the code and everything's perfect. You'll get away with it and I won't even know about it. But if your code's wrong in any way, now your test cases are wrong and just everything's wrong. And then you get failed the correct solution in Autolab. Is usually what you'll see there, which means your test cases are testing the wrong thing because they were generated with incorrect code. So just be aware of that. I do encourage you to write your test cases first and then write the code. And then run the test cases as you're coding to be able to check if it's right. Yeah. Yes. So for the cities.csv, what I recommend is finding some cities with very few finding some countries with very few cities. So don't, like one of my examples, I use Japan for the country code. I wouldn't use Japan for any test cases that is returning city data. Like average population, like I don't even know how many lines in that file, probably thousands of lines in the file, thousands of cities in Japan. And you're not going to verify that manually. So pick a country. The first country in the cities.csv file doesn't have very many cities, so it's nice to use that one as a start. But that country doesn't have any regions with more than one city. So going through the list, finding a country with a region with only a couple cities would be one of the things to do. But yeah, it's looking through that and trying to find the easiest ones to code up. To generate my test cases for testing your submissions, I actually wrote a script that counts the number of, I should add this as a task actually now that I think about it, that returns a map of the number of cities in each country. I use that to, bless you, I used that to find the small countries and then went there to pick out my test cases. Yeah, sometimes figuring out the test. It's not uncommon to spend more time on the test cases than the code itself. In this class, in industry, like in programming, a lot of professional code bases, the testing code, there actually be more code in the test than the project itself. It's testing is that important where it deserves a lot of time. Which you might not feel this pain yet, but testing, I'd say the main goal of testing is to decrease the amount of time you spend debugging and chasing down errors. Testing really saves time there. So it's a tough upfront cost, but it does save a lot of time in the future. But it is hard to get any developer to write tests. a lot of us would rather just debug. All right, so let's get to, let me catch up on chat. How are we going to grade your test? So grading your test happens the same for all these tests coming up, is I run it on a correct solution, your solution, and then a variety of incorrect solutions, and your tests have to discern the difference between correct and incorrect solutions. Acceptable. I recommend writing the test before the code, which I'm going to give an example of right now. I'm going to write the testing before the code on this one. So let's write a method that's going to compute a histogram of a list of ints. So it's going to take a list of ints. It's going to return a histogram, which is being a map of int to int, which maps each unique int in the list to the number of times it appears in the list. It's going to be our histogram. We're going to write tests for that and then implement it. And if we get to it, I didn't get to it in the last lecture, maybe we will this time, write a method that takes a list in the same format and returns all of the most frequent values appearing in the list. So the most common value, the one that appears most often, that's the return value. But if there's a tie, return all of them. So, and even if there's just one, return a list containing that one value. And that's my last slide. I just want to show that one so I don't have to go back to the slides. And let's do this. So I want to start with my test cases for this histogram. But before you write any test cases for something, you at least need a method to call. So I don't have anything here for histogram. So I want to write something there so I have a method to call. I'm going to write what's called the method header, which is going to be histogram. Histogram is going to take, which I'm just going to call input, is going to take a list of ints. Oh my goodness. A list of ints, it's going to return a map of int to int. How did I do that twice? The same mistake twice in a row. And I'm going to do what's called stubbing out the method. I'm going to stub out this method. I'm not ready to write the code yet. I'm just going to have any return value that doesn't give me an error. So I'm just always going to return an empty map. Just something that doesn't give me an error. So I can get rid of all those red squiggly lines. So now that I have the definition of my method, or not definition, the header of my method, now I'm ready to go here and start writing my tests for that method. So I want to use the same structure, and I'll write the structure pretty quick this time because we just saw it. But I want to use that same structure of creating a map of my test cases and then iterating over them to be able to test my method. So first, import, I'll just leave my import there. Val test cases, which is going to be a map. This is going to be a little much. It's going to be a map from the inputs to the outputs. The inputs are lists of ints, and the outputs are maps of int to int. So we talked about nesting data structures a few times in this lecture. I said we wouldn't do it much, but for test cases, it does get a little bit much, but not too bad. But we have to map the inputs to the outputs. And let's get at least one test case here. A list of 1, 2, 3 is going to map to a map of 1 to 1, 2 to 1, 3 to 1. So what this means is that 1 appears in the input list 1 time, 2 appears in the input list 1 time, and 3 appears in the input list 1 time. Let's copy this. Let's get one that's a little bit more involved. A 2, 2, get a 3 up here, and a 3 here. So if I did this right, 1 is 3 times, 2 is twice, and 3 is twice. So something with some duplicates, getting a little bit more involved. Example. Let's do one more before we write the rest of this. And let's do one with, and here we're just thinking of all the different mistakes one could make when writing the code. I want to get a nice variety of inputs to catch all those mistakes. Something with all the same values, which should be 7, right? And I want to start mixing this up. What if I have a mix of positive and negative values with the same magnitude? I want to make sure the code can handle that. -1 appears 3 times. And let's just go all the way. Let's get our edge case. An empty list should return an empty map. What else do we want in here? I guess something with just 1 value. Oh, I hit the wrong thing. A decent, a good start to a test suite. This would probably be enough to pass the testing in Autolab if this were a task on a project. But not necessarily, the Autolab bar isn't meant to be too high. You should be able to get over that bar without too much difficulty. But some of you will say that I'm wrong by the time you get into the testing, I know, but it's not meant to be too high. Input, expected output. In test cases, val computed, what did I call it last time? Actual output, map, int equals numbers dot histogram input assert actual output equal expected output. And since I'm testing maps, I have no concern about order. I'm just going to hit it with the equal and call it a day. Yeah, so sometimes I do explicitly say in the homework doc that the edge cases shouldn't be tested. The average population of a country with no cities is undefined. So I won't test it, you don't test it, it'll be good. I probably should update that and just say it should be 0.0, but I didn't do that. So here's my test suite. I'm going to run this and see if my code passes. I'm fine, at least for lecture, I'm fine with this test suite. I'd want to add a few more if I had more time. And my code fails this test. Oh no, what do we do? Well, it's because we have no code. But now that we have a test suite that we're feeling pretty good about, when we're writing our code, if we write our code, take a pass at it, and run the test suite, we have that test suite right there at the press of a button to be able to see if we're doing good on our code. If we pass those tests, then we know we're feeling pretty good about our code, and I'm feeling good enough to submit to Autolab and see what Autolab says about it. So let's write some code and see if we can get these tests passing. I'll do this pretty quick because I want to focus on the testing side of today's lecture. Oh, shit, it's 2:44. So let's write this code up quick. And we didn't get to most frequent in the last lecture, so we didn't hear too. That's fine. But var result. So I'm going to create a map of int to int, which is going to be what I'm going to end up returning, equals a new map. This is what I'm going to end up returning, so I'm going to slap that at the end of my method, so it's going to be returned. And I'm going to need a for loop that iterates over the values of this input array list. And I'm going to ask one question in this. If this map, my result map, doesn't contains values, if my map doesn't contain the value that I'm looking at, I want to initialize that value in my map. So I'm going to say result equals, I'll skip the shorthand and use the expanded notation instead of plus equals for now. Equals value, mapping to 0. So I'm going to say, oh, I did put an S there too. So I'm going to say if I've never seen this value before, initialize my map to say that, hey, this is a value that exists in the input list, initialize it to 1. And then whether I've seen it or not, I want to increment my map and say, hey, I've seen this value an additional time. Result equals result plus value mapping to the value that is already currently in the map, which if it's the first time I've seen it is currently 0. So result of value and pop it up by 1. Now we have to be careful with our order of operation here. Scala is going to do the order of operation in a different way. I believe it's creating the key value pair and then trying to add 1 to it. So if you get errors like that, slap some more parentheses on there to make sure you get the right order of operation. Make sure that addition is computed before creating the key value pair. Then I'm feeling good about my code. I'm going to run my tests. And I'm passing. So I'm feeling good about my code. I'm ready to submit to Autolab. Most frequent, I did leave the test cases here just so we could at least look at them. Again, with most frequent, the important thing here is the dot sorted. We have lists of values and we don't care about their order. I'm going to sort both lists and then do the comparison. And I'm going to push this code to Autolab. So if you're following along with the examples repo, you want to see all the code that I just submitted. I'll say lecture examples and push that to Autolab, or not to Autolab, GitHub, so you can see that code right away. All right, any questions? I got one for you then.